Right, okay. I put it to record. Firstly, I want to know one thing, whether you have done this lesson before with your existing teacher, current teacher. Because this is a new thing. If you haven't done, if you have done, still this is going to be new, because this part is really out of reach for most of the students, but it is not really hard. By the way, let me know whether you have done this blackbody radiation before. Blackbody radiation. Let me know whether you have done the blackbody radiation before, and what is blackbody radiation, if you have any idea regarding that one. By the way, let me explain you blackbody radiation. Before going for the blackbody radiation, I would like to remind you something like electromagnetic spectrum. According to electromagnetic spectrum, this blackbody radiation belongs to one specific part. That's why it's really important to remember you basically regarding black body radiation, right? Let me teach you that black body radiation. Before that, I want to explain you what is the base, what are the basic properties of this one. What is it called? EM spectrum, electromagnetic spectrum. Okay. So in the electromagnetic spectrum, left-hand side ones have the lower wavelength, meanwhile, right-hand side have the higher wavelength. In the other way, when the wavelength is lower, according to this equation, you know that V equals to F lambda. What about then? This V is a constant value, because the speed of light in the air is constant throughout the universe. It's a universal constant in the empty space as well as normal air. Mostly in the empty space, that means in the vacuum. It's a constant. So somehow, if you vary this wavelength, when the wavelength is lower, the frequency is higher. You have highest frequency here and the lowest frequency at the right hand side. You have to know these parts, right? Actually, you have to know these parts. In the throughout of this entire journey of matter and radiation. Hi. එතකොට මේ there is a one guy, Atif, Atif, I don't know. So Atif, are you comfortable with kind of Sinhalese or not? I don't know. Atif, I'm talking to you. Yes, okay. මම ඉඳලා හිටලා පොඩියට සිංහලෙන් වචනයක් දෙයක් දානවා සමහර තැන්වලදී. මට කියන්න මේ EM spectrum එක ගැන ඔයාලා දෙයක් දන්නවද? Do you know something regarding this EM spectrum? Because this EM spectrum is really important. And you will instantly, today itself, you will learn when the frequency goes high, energy also goes high, but you will learn, but I will put that. And the energy also lower in the right hand side, only the wavelength is bigger. Right. In that spectrum, we are always dealing with the visible spectrum. This is the visible light, visible region. And something below visible region, it is supposed to be above visible region. Firstly, you will find UV light, ultraviolet. And ultraviolet is a kind of harmful radiation that may cause us blindness and kind of cancers and many other problems, as well as it's really important radiation for us as well. After that, X-ray and gamma. And below, this is what the most important thing in this Blackbody radiation. The radiation now I'm going to teach you. This region, this part is extremely important. That is called IR. Infrared region. Why the infrared region is really important in case of the blackbody radiation? Can anybody tell me? කාට හරි කියන්න පුළුවන්ද ඇයි මේ blackbody radiation එක මෙච්චරට මෙන්න මේ infrared region එක වැදගත් වෙන්නේ කියලා? Why the heck is this infrared region is so important, so much important? නිකන් දන්නවා නම් පොඩ්ඩක් කෙටියෙන් බොහොම short and sweet answer එකක් දාන්න බං දුක් ගාලා. දන්නේ නැත්නම් ප්‍රශ්නයක් නැහැ මං කියලා දෙන්න. If you know, that's really going to be important. If you don't know, it doesn't matter. Just let me know. Okay, because this infrared region is known as thermal radiation. What is it known as? Thermal radiation. This infrared region is the one which is known as thermal radiation. Blackbody radiation means it is not about black, right? It is not about black. Blackbody means there's a two sides in that. There are two sides. One is the white body, other one is the black body. All together we call them as black body. Not the thing like a black guy like me. Black body radiation, right? Black body radiation. Infrared region is extremely important. Why? Now I explained to you this part. If you want to copy this just take a screenshot of this one. Onna menna meke podi screenshot එකක් ගහගන්න. Right? Just get a one screenshot of this one. I will just move aside. Okay. I gave you enough time. So this one is not really hard. Actually, it's really easy. Why? Infrared. Why is that infrared region is so important? Now imagine if you heat something, if you just heat something, if this matter X, you are going to heat it up. What should happen to the particles of this one? If I select one particle, and when you put some heat to this particle begins to vibrate from its original position. It's like this. Now imagine if I am a kind of the traditional Indian dancer, then I may know this thing, but I'm not a dancer, but I know. They know this neck dance thing. Now if the tempo goes high, what would happen? Even if the tempo goes even higher, if the tempo goes even higher, I can't do that because it will dislodge my neck from this point, right? That's what the same thing happens because this particle begins to vibrate faster. Because I'm a Dracula, that's why. Then because it will just increase the vibration. As the vibration increase, it will emit what? Heat radiation. ඔන්නෝක ගැන තමයි අද කතා කරන්නේ. මම මේ background එකත් එක්ක කියලා ආවේ. Okay, this is the World Cup season. Tomorrow it is the final. But in this World Cup, we miss really important thing in terms of DRS. What is the DRS? DRS means the decision review system. Whether you are given out, you can review and get whether you are out or not. You can confirm. But there is one thing it was missing. It's a very bad miss. If you are a cricket enthusiastic, you know what we have missed in this one, in DRS system. That thing is known as hotspot camera. What is it? Hotspot camera. Why hotspot camera? If you are a cricket enthusiastic, you may know. If you are not a cricket enthusiastic, you wouldn't know. So මම ඔයාලට දැන් මේ තත්පරේ පෙන්නන්නම් මොකක්ද hotspot camera කියලා. ඒක ගොඩක් මේ lesson එකට important. It's really important in this lesson to know. Blackbody radiation එක වෙන්නේ ඇයි කියලාත් ඔයාලට හරියට තේරෙයි. මම දැන් තප්පරයක් ඇතුළත මේ පෙන්නන මෙන්න මේ ක්ලිප් එක බලපුවාම තප්පරයක් ඉන්නවා. Just wait there. For 1 second. Now see. 1 minute, share sound.
Must be LBW, must be LBW. And is LBW. Well, if he didn't get it, he's gone for all money. In fact, there were two. Yeah, that player's response. Alistair Cook was just so quick to say, yeah, I'm referring that one. And no excitement, Smith, I think, or wherever Martin Hughes is so confident this. That he's
now see this important point.
To see one of the great innovations in the game, hotspot.
Now see this very important point. So can you see there is a white spot in this region? මෙන්න මෙතන මේ white spot එකක් තියෙනවා පේනවද මගේ මේ පෙන්නන්නේ න red එකකින්? Can you see there is a white spot? Huh? Can you see this white spot there? When I mean white spot, it is really important. That is what the hotspot we are talking about. That's what the hotspot we are talking about.
A little inside edge, and Cook hasn't even bothered. He knows that the mind network will look up.
There's a really cross of technology involved. Then the umpire will have to.
Had a pretty good game until that decision.
He says it's spot and it was cancelled out. Okay, I'm going to stop sharing. Now, did you get certain clear idea about what is that hotspot? Hari, Lamai, did you get an idea about the hotspot? Other time delay එකක් මොකක් හරි තියෙනවා වගේ signal failure එකක මම දන්නේ නැහැ මේ චූටි අවුලක් මට පෙනුණා. So did you see what is the hotspot? The hotspot occur all due to one reason. What is that reason? Collision. When there is a sufficient collision, the particle will begin to vibrate. When the particles oscillate, most of the matter have their natural oscillation. We know that natural oscillation is a very important phenomena called what? Resonance. It's called resonance. The resonance can only occur for natural frequency for most of the material under IR spectrum. ඒ IR වලදී තමයි ගොඩක් වෙලාවට natural vibration එක occur වෙන්නේ. හරි. මාව lag වෙනවද ළමයි? Am I lagging? Am I lagging? ළමයි මාව lag වෙනවද? ටක් ගාලා කියන්න am I lagging? I have to change the network otherwise. Guys, just let me know whether my voice is lagging. One student just is keep telling me that only sometimes, not frequently. Right, okay. A bit, okay. Have a good look at. That is the reason. So vibration may occur. Now in the cricket bat case, if the cricket ball, 1 minute, I have a cricket ball. So once the cricket ball hit, so when it hit, what would happen? The particles will begin to vibrate faster and it will produce some infrared radiation. So it will become hot because if you just keep rubbing this one, it is also going to make something hit me. Just try to rub your palm. You can see it's getting hotter. So when it gets hot, it will release IR radiation. That's the reason. හරි නේද? මේ IR radiation කතන්දරේ තේරෙන්නේ නැතිනේ. right? Okay, now this is what most important part, and it will lay the foundation to most of the radiation activity. Now, if there is a radiation occur, this radiation will be irradiated throughout the space evenly, all the directions evenly. For bodies which they are under some temperature of T. Right. Okay. But what is a black body, by the way? මම මේ ගැන කතා කරන්නම් තව විනාඩි 10කින්. What is a black body? A black body is a body which can absorb and emit radiations in all the wavelengths. ඒ කියන්නේ තියෙන හැම wavelength එකම radiation absorb කරගන්නත් පුළුවන්, emit කරන්නත් පුළුවන්. Absorb කරන්නත් පුළුවන්, emit කරන්නත් පුළුවන්. That is the importance. That means you can absorb radiation, you can emit all the radiations back. This type of body is known as a black body. So put a topic, very big heading, that is the radioactivity, sorry, matter and radiation. Under that, black body radiation. And under that one, very small topic, a black body. A black body. Only remember the things what I told you as a just factors. This is not a theory class. This is more than a theory class. This is not a revision even, but something even advanced. So you don't have time to write all the trivial things, but you have to write the basics. What is a black body? We have to know what is a black body first. Write the basics of a black body. Whenever you are writing a definition, but I normally use a hashtag to emphasize, make a patta important කියලා emphasize කරන්න, I normally use a hashtag. ඔයාලා කැමති එකක් පාවිච්චි කරන්න $sign හරි ඕන එකක්. And put this, a body which absorb and emit wavelengths, a body which absorb and emit all the wavelengths, sorry, radiations in all the wavelengths. එහෙම ඒවා මේ ලෝකේ කොහෙවත් නැහැ. අපි එහෙම කියනවා. Right? Okay. Now I am going to stop my camera for a while. I'm going to explain you something using even advanced technology. Hari. Right. Let me stop the camera for a while. It is really important technology called what? Blackbody radiation. Let's see what is a blackbody radiation, by the way. Okay. I think you guys can see my screen, what I'm sharing now, ne? Okay, Lamai. Have a really good look at a black body. In case of a black body, we have to use whether which side is just going to, which color is going to emit more radiations. We use a thing called Leslie cube. What? A Leslie cube. What is a Leslie cube? Let's see. What is it? This one. This one. Have a good look at. A Leslie cube is just a cube you can also create at your own home. So you can create a Leslie cube at your own place, at your own home. It's not a very big deal, right? It's such a simple thing. So whenever you are about to create a certain Leslie cube, just get a certain cube in equally sized. One side should be covered with shiny black, other one matte white. There are less shiny silver and some other different colors. You may color it using some different colors, but one side should be very matte white, other side should be shiny black and matte black. So you can use this one using an infrared detector. and measure the amount of temperature. You know what is an infrared detector? ඔයාලට මතකද කොරෝනා දවස්වල you were held certain pistol looking device at those shopping centers and medical centers, even at your school? මෙන්න මෙහෙම ගන්න එකක් වගේ එකක් ඔලුවට ඇල්ලුවානේ. So that is nothing other than what? Simple radiation measurement device. This device can measure temperature. It was calibrated to measure the temperature, but this was being used to measure the temperature. But most of the heat temperature was recorded at the black side. Where? The black side. That means the black color emits what? Most of the radiation emitted. Black color is responsible for the emission of most colors. Right? මම පොඩි ප්‍රශ්නයක් අහන්න. දැන් ඔය ක්‍රිකට් මැච් එකක් එහෙම ගහද්දී අපිට අඳන්නේ මොකක්ද? white color shirt එකක් නේ. We are just wearing certain white colored uniform. Why? Guys, can you hear me? මාව ඇහෙනවනේ හොඳට? ඔයාලට මාව ඇහෙනවනේ? We normally wear white color outfit during playing a test match. Why? It's really hot out there. We have to wear something that doesn't absorb most of the radiation. හරිද? මේක heat කරලානේ තියෙන්නේ මේ ඇතුළට heat එකක් high කරලා. So black color absorb and emit heat very fast. So if you are wearing a black color during playing a test cricket match, you die. So now we are just about to observe what is a black body. මේ black body එකක් කියන්නේ මොන වගේ එකක්ද කියලා බලමු. Laboratory you can create a small box using a small box, and this box can be colored entirely using black color internally. ඒ කියන්නේ මේක ඇතුලෙන් color කරලා තියෙනවා black වලින්. කිසිම light ray එකකට ඔක ඇතුලට ආවොත් ටක් ගාලා උරා ගන්නවා. අපි දැන් හොයාගත්තානේ black color එකෙන් absorb කරගන්න කියලා. We just found that black color is the one responsible for absorption a lot. Right. Imagine this very bright white color line, actually a light ray which hit here. There is a pinpoint. ඒ කියන්නේ පොඩි pinpoint එකක් තියෙද්දි මෙයා මෙහෙට හැරිලා යනවා, මෙහෙට හැරිලා යනවා. Right. And it absorbs as well. Then just a bit of absorption more. Each time when it bounce back, it will absorb and absorb and absorb. Now it has reduced the line with see, line with reducers and reducers, finally vanish. The same thing to happen to this side as well, and bounce and bounce and bounce and bounce and vanish. So this one is more likely, but this one has given more likely absorption and absorption and absorption and absorption. හරිද? Making absorb වෙලා ඉවර වෙලා යනවා. තේරුණාද ළමයි? Then finally it will fully get absorbed. මේක සම්පූර්ණයෙන්ම වගේ absorb වෙලා ඉවර වෙනවා. හරි නේද? It will fully completely get absorbed. Hari. This is what we used to call as a black body and the black body radiation. Hari neda? Hari. I will come back to original screen again. That means the physical screen back. Hari. Right. Lama, did you get any idea? Did you get any idea about that? How does radiation absorption things? So for a black body, how to remember, there are no perfect black body. All the radiation emission, we can consider our sun as something which emits all the radiation. Harini, sun එකේ හැමතිස්සෙම X-ray වල ඉඳන් හැම එකම emit කරනවානේ. Yes, you can take it as all the radiation emitter. But all the radiation absorber, fully, completely absorber. A black body. Black body means black hole. Regular black hole. Black hole එකක් අපිට ගන්න පුළුවන් ඔක්කොම radiations absorb කරනවා කියලා. So we can consider like that. But there is a one problem. What is it? Can you just merge a sun and a black hole together and create a perfect black body? No. We can technically create a perfect black body. If there is a perfect black body, that's how we imagine in physics. If there is a certain perfect black body, the black body radiation may look like this way. The emission of energy per unit time. What is it? Emission of radiation energy per unit time. That means the power per unit area will be proportional to the fourth power of temperature. That means the thermodynamic temperature, that is nothing other than it's on Kelvin value. Kelvin වලින් තියෙන fourth power එකට equal කියලා කියනවා. We say that it is 100% equals to proportional to fourth power. That's only for what? One unit area. So to remove this proportionality constant, I may put something proportionality constant sigma t to the power 4. So this is called the Stepan law. Now open a bracket. So put new topic, subtopic called Stepan-Boltzmann law. Stepan-Boltzmann law. Open a bracket, sorry, topic and write Stepan-Boltzmann law. You may draw this later. Firstly, write this. And again, you have to go for another definition. As I said, you put certain symbol like this and write. මෙන්න මේ වගේ symbol එකක් දාලා ලියන්න. What is it going to be? එක මොන වගේ එකක්ද? හරි. ලියන්න එහෙමනම්. The radiation energy emission of radiation energy per unit time per unit area of a black body is directly proportional to the fourth power this fourth power of thermodynamic temperature or absolute temperature. එහෙම ලිව්වත් කමක් නැහැ. Thermodynamic temperature or absolute temperature of an object. ටක් ගාලා මේක ලියා ගන්න. ඊට පස්සේ මේ equation එක දාගන්න. I will tell you what are the reasons and draw this diagram first. An object which is heated up and E, emission of energy per unit area under unit time. It may look like this. හරි දාගන්නකෝ. Okay, I will erase this one quickly. So you'd better write this one. If you have written this one, now write the meanings. What is E? E is energy emitted per radiation energy emitted per unit time. radiation energy emitted per unit time. The unit of that one is none other than watt. That is watt. And T to the power 4. T to the power 4 means fourth power of absolute temperature. In Kelvin, so the unit is K to the power 4. So finally this one. Finally, what? This symbol, it is called the Boltzmann constant. Boltzmann constant, Stepan constant. So what is it? That one is W m minus 2 K minus 4. මේක තමයි මේ unit එක. W m minus 2 K minus 4. K to the power minus 4. ටග්ගල් ලියාගන්න. Okay, guys. හරි නේද? දැන් ලියන්න. Now write another point. If it is not a unit, if the body is not a unit area. ඒ කියන්නේ unit හරියටම square meter එකක් විතරක් තියෙන එකක් විතරයි නම් විතරයි මේක set වෙන්නේ. එහෙම නැත්නම් so the equation may change as following. If the body has an area of A and the temperature of T, it may emit radiation like this, like our sun. So what is it going to be? E equals to sigma A T to the power 4. Sigma A T to the power 4. Now copy this. Sigma A T to the power 4. Sigma A T to the power 4. Right, just leave this like this and let's move on to some calculations that to be made in the tube that I provided you. Firstly, I will explain you the ready-made done ones in the tube. Then I provide you a very small tube including a A-level question, that is the 2004 question. Let's go for that one. Before that, I will explain you some of the ready-made questions, then go for the tube and try some questions. And after that, we have to come back to here to do what? A thing called Wien's displacement law and Planck's hypothesis. Then we go for the A-level questions. පිටක් ගාලා එකට යමු. මම ස්ක්‍රීන් එක ෂෙයා කරලා ඒක කරන්න. I'm talking about this tube. Right? I'm talking about this tube. But before trying this one, I have to show you one important thing. And I'm talking about the other tube, this one that you may see here. So I have given all the basic theory like blackbody radiation now. Sorry. In the sense of Stepan law, I have given you the Stepan-Boltzmann law here. Explained really with all the points you want. හරි. මම දැන් මේක එක එක්සැම්පල් එකක් මෙතනම අරන් පෙන්නන්නම්. අරන් පෙන්නලා ටක් ගාලා ගණන් ටික try කරමු. Right. One example, that's enough. හරි. මේ බලන්නකෝ. In this one. So actually get the question here. Right. The question is here: a filament of a light bulb is cylindrical with a length of 20 millimeter and the radius of 0.05 millimeter. The filament is maintained at the temperature of 5000 Kelvin. Kelvin 5000ක තමයි මෙයාව maintain කරන් තියාගෙන ඉන්නේ. Right? It is maintained under certain temperature of 5000 Kelvin by electric current. The filament behave approximately as a blackbody. ඒ කියන්නේ blackbody එකක් වගේ ඔන්න මෙන්න මෙයා වැඩ කරනවා. The emitting radiation isotropically at night you observe the light bulb from a distance 10 kilometer with the pupil of your eye dilated to radius of 3 millimeter. What is the total power radiated by the filament? හොඳට බලන්න. What is the total power radiated by the filament? Okay, it says here where dP over dA is the power radiated per unit area of the surface. Sigma is the Boltzmann constant, 5.6 into 10 to the power 8, Wm minus 2, K minus 4. Hi, what you have to do? You only have to do one really simple thing. That is what? Area. Here, the area. What is the area may look like? Filament is like a cylinder. So cylindrical area, how to get the cylindrical area? Surface area. You know the area of a cylinder is 2 pi r into L. That is why it was given here 2 pi r L. And sigma is the Boltzmann constant. You have to substitute. Then the temperature, that is where temperature is some 5000 Kelvin and have to substitute. See, 2 pi, area is 2 pi into 0.05 into 10 to the power minus 3 and 0.02, that means the radius, diameter, and Boltzmann constant here, and the Kelvin temperature as the power 4. If you substitute these values properly, you may get the value of 220 watts as the power. Hari. එච්චරයි. අපි එහෙමම යමුද example ගානව explain කරානේ මේ ඇති. ඔහොමම ගිහලා try එකක් දෙමු. Qt එකේ තියෙන මෙන්න මේ ගාන. පළවෙනි ගාන. ළමයින්ට මම පළවෙනි ගණන් දෙක හදන්න. I will leave you some time of what? මම වල පොඩි time එකක් දෙන්නම්. මේ ගාන මම explain කරනවා වැඩි වෙලාවක් අරන්. I will explain you this one taking more time. Because the ready-made ones you can observe at your home. Let me give you enough time. I will give time like 10 minutes for both. ඔයාලට මම විනාඩි 10ක් දෙන්න. Okay, your timer clicks now. It starts now. Try and WhatsApp me once you have done. මේ ගණන් දෙකම හදන්න තමයි ඔය ටයිම් එක දුන්නේ. එකකට විනාඩි 5ක් ඇත. try කරන්න ළමයි. Only equation you have to remember is, if you have really new to this lesson, E equals sigma A T4. මෙච්චරයි. sigma වල value එකත් අමතකයි නම් මම ඒකත් ලියන්න. sigma is 5.6 into 10 to the power minus 8 Wm minus 2 K minus 4. A is area. T is what? Temperature in Kelvin. ඒක හොඳට මතක තියාගන්න. Temperature in Kelvin. Temperature in Kelvin. හරි. ටක් ගාලා ඔය ටික දාගන්න. පළවෙනි ගාන නම් හරිම ලේසි. විනාඩි 10ට කලින් ඉවර කරන්න පුළුවන් නම් ඒත් මට කියන්න ඕනේ. හරි. Your time started. Try this.
Recording in progress.
ඉවරයිද කරලා කරන ගමන්
ළමයි මොකද කියන්නේ? හිර වෙලා ඉන්නවද කරගන්න පුළුවන්ද නැත්නම් ඉවරයිද? If you are struggling, I will start to discuss you the question. So if you have done it, it doesn't matter. ළමයි. You have 4 minutes more. මට කියන්න බෑනේ ඔහොම මම ඩිස්කස් කරන්න ගන්නද ඔයාලා හදනවද? හදලා ඉවරයි. Okay, you have some 8 seconds. Right, that's that. Right. Let me explain you the first question. You have to refer to this equation that is given here. According to this equation, the temperature is 127 Celsius and the surface area is 10 square centimeter. Now you have given those basic data and sigma is, as I told you, 5.6 into 10 to the power minus 8, 5.6 into 10 to the power minus 8 and multiply that by 10 into 10 to the power minus 4. As why did I multiply by 10 to the power minus 4? It is because this one is given in square centimeter. මේක දීලා තියෙන square centimeters වලින් මිලවයි. එතකොට square meters වලට convert කරන්න ඔයාලට 10 to the power minus 4 වලින් multiply කරන්න වෙනවා. And the temperature is like 127, but you know when we are converting Celsius value to Kelvin, you have to add 273. Then it is going to be 127 plus 273. That means it is some 400 Kelvin. So it is 400 and power 4. You have to apply these values and get the result. I will do that in my scientific calculator and let you know the answer. To the power minus 8 and multiply that by 10 into 10 to the power minus 4 and again 400 to the power 4. Right. And finally, you may get very small possible answer. මේක හරි පොඩි energy එකක් absorb කරන්නේ. It will absorb 1.433 W. What මෙන්න මෙච්චර පොඩි ප්‍රමාණයක් තමයි absorb කරලා තියෙන්නේ. හරිනේ? Emission, sorry, it has emitted under this much of lower temperature. එන පොඩි ප්‍රමාණයක් තමයි emit කරලා තියෙන්නේ. හරි නේද? මේ උත්තරේ ඔයාලගේ හරිද? ඔයාලා දාන්න මේ උත්තරේ ආවද? හරිද කියලා ගන්න. මොකද මේ කියපු දේ තේරුණාද කියලා බලා ගන්න එපා නෝනට. තේරුම් නැත්නම් මම තව ටිකක් තේරුම් කරලා If you couldn't understand this, then I'll have to explain you a bit. Okay, at least write this down. I think I gave you enough time to write this. Two black bodies P and Q made out of identical materials have their radii 8 centimeter and 2 centimeter. Those were maintained at 127 degrees Celsius and 527 degrees Celsius respectively. Find out the ratio of the thermal radiation emission rates of P and Q. Right. P වලට වෙනම හොයන්න Q වලට වෙනම හොයන්න. What is P may look like? P is what? With a radius of 8 centimeter, of 8 centimeter, and it emits some radiation which was maintained at 127 degrees Celsius. And the other one Q, same material, but it has the radius of 2 centimeter, and the amount of radiation emission is take place, which is under 527 degrees Celsius. Now I have to apply these two values and obtain the answers for this one. Nothing other than I have only one equation for Stepan equation, that is sigma A e to the power 4. So find out area of a sphere for pi r to the power 2. Then I will write sigma for pi r to the power 2 times t to the power 4. I have to come to these parts. මට මේවා ටිකට එන්න වෙනවා. ඇවිල්ලා තමයි substitute කරන්නේ. Then I will substitute this value. I know this one. This is a given value like 5.7 into 10 to the power minus 8 W m minus 2 k minus 4. And just multiply 4 and multiply pi value like 22/7 and r value that was like 8 into 10 to the power minus 2 because centimeters to meters conversion and a square. And finally temperature, that is what 127 is nothing like 400 Kelvin. මේක මතක තියාගන්න ඕනේ. 400 and 10 power 4. These are the substitutions that I have to make, and I will substitute the answers and get the answer in my scientific calc. Minus 8 into 4 times pi so 400 to the power 4. Okay, I'll get some power which is under something somewhere like 170.3 watt. මෙන්න මම left hand side එකට ගත්තා. හරි. from right hand side එකටත් මේ වැඩේම කරන්න යන්න. I'm going to do the same thing to the right hand side too. The same equation. Now you know what to do. Sigma is 5.7 into 10 to the power minus 8 times R is here 4 and 22/7 times. I will write the radius here. What is the radius? 2 centimeters. 2 into 10 to the power minus 2 and power 2. And the temperature is now a big value. It is 800. 800 power 4. I will tell you an easy way to get this. මම මේක කරන්න පුළුවන් දෙන පට්ට ලේසි විදියකුත් කියලා දෙන්නම්. රේෂියෝ එක ගන්න මම මුලින්ම හරි විදියට කියලා දෙන්නම්. පස්සේ MCQ එකකදී වගේ මේක දැක්කොත් මේ වගේ බඩගගා ඉන්න බෑ අපිට. තියෙනවා හරිම ලේසි ක්‍රමයක්. මේක මම කියලා දෙන්නම් තව ටිකක්. මම මේකේ වැලියු එක ගන්නම්. It's 800 to the power. හරි ළමයි. Ironically, I am getting certain different answer. 117.35 here 35 as well. What? So what is the ratio? It is 1:1. මම මේක මීට වඩා හරිම ඉක්මන් ක්‍රමයකින් තරම් පෙන්නනවා. අක්කල ඔබ දාගෙන මේ වගේ ප්‍රශ්න MCQ වලට එනවා. මේ වගේ බඩගගා හදන්න බෑ. විනාඩියකට කලින් අපි හදාගන්න ඕනේ. කොහොමද හදන්නේ නේ? වහනම් කියේ කම්පැනි හදන්න ඕනේ කියලා. මේවා අමාරු වැඩ නෙමෙයි. ඇති දෙයක් නෙමෙයි. I will tell you how to do that. මේක ලියාගෙන ඉවර නම් කියන්න මට ටක් කරලා මෙසේජ් එක ඩ්‍රොප් කරන්න. මම කෙටි ක්‍රමෙන් කියලා දෙන්න යනවා. ෂෝට් කට් මෙතන. මම මේක නම් එකක්වත් දාන්න නැතුව ලස්සනට කරන්න පුළුවන් හොඳ ෂෝට් කට් මෙතඩ් එකක් තියෙනවා. තව තත්පර 20ක් දෙන්න ඕක ලියා ගන්න. You have only 20 seconds more. Ten seconds more. 5 seconds more. And stop writing. හරි. දැන් හොඳට බලා ගන්න මම මෙන්න මේ ඩයග්‍රෑම් දෙක විතරක් මට උන වෙනවා. ටිකක් දෙනවා. බෝනස් උත් සම්පූර්ණ තියෙනවා. ඔව් ඒක ඕනේ. මම MCQ එකක් ඉඳන් මම අලුතෙන් අඳින්නම් කොයිද? I will draw it again in the name. 8 centimeter and 127. The other one is 2 centimeter 527. Okay. What is my equation, modified equation for energy? Equals sigma A T4. But here it is the radius, so area is what? 4 pi r square. Then the equation becomes 4 sigma 4 pi r square T4. Make any. Mom, make equation I will write this one in this way. E1 equals to sigma 4 pi r1 square T1 4. The other one is E2 is equal to sigma 4 pi r2 square T2 4. මම මේ දෙන්නව divide කරගත්තා නම් අපි E1 over E2 equals දාපු ගමන් sigma ට sigma කැපිලා යනවා 4 pi ට 4 pi කැපිලා යනවා. ඇති වැඩක් නැහැ. R1 square T1 4 R2 square T4 T2 4 මේවා ටික දවසක් ප්‍රැක්ටිස් කරපු ළමෙක්ට මෙච්චර දුර කර කර ඉන්නේ නෑ යා. එයා ගෙලින්ම මෙතෙන්ට දාගන්නවා. මොකද එයාගේ ඇහැට උරු. මේවා කැපිලා යනවා කියලා තේරෙනවා. අන්න ඒකයි ඔයාලා එක්සෑම් එකට කලින් කරගන්න. ඔයාලා හිතන්නකෝ අද උගන්වලා ලබන සතිය එක්සෑම් එක කරන්න දුන්නොත් එහෙම ඒ ලෙවල් මේ පාඩම හරිය ලේසි. මම හැමතිස්සෙම කියනවා. මේක මාර ලේසි. This one is a really easy lesson. But the problem is teachers are teaching this one with the very last moment. Then you have no other option. ඔයාලා ඉගෙන වෙනවා මාන. එහෙම කරගන්න ඕනේ නැහැ. එහෙම ඉගෙන ගන්න ඕනේ නැහැ. දැන් නිකන් ප්‍රැක්ටිස් කරලා තියාගත්තාම මේවා දැක්කම නිකන් කියලා. මෙන්න මේක ගෙලින්ම ලියන්න පුළුවන්. ගානට හදාගන්න පුළුවන්. Right. What would I do is the first one 8 square. The other one is 404. Right. යට එකේ 2 to the power 2 times what is 800. ඉතින් මේක හරියට ලේසි. මෙතන 2 to මේක 4යි එන්නේ මෙතන 64යි. කැපිලා යනවනේ කියන්නේ 16. මෙතන 4 වලින් පවර් එකක්. එහෙනම් ඔයාලට තේරෙනවා මේක x to the power 2 නම් මෙතන 2x to the power 2. මේක දිහා බලපු ගමන් අපිට මෙහෙම ගන්න පුළුවන්. x to the power 2. sorry 2x to the power 2. මම x කරලා දාගන්න. මේක x to the power. මෙතන y to the power 4. මෙතන කීයද? 2y to the power 4. මම මේක මෙන්න මෙහෙම දාගන්නවා. මේ වගේ දෙගුණයක් මෙතන තියෙනවා. මේ වගේ දෙගුණයක් මෙතන තියෙනවා. හරි. What would happen? Only 4 remaining on top here because x square is gone off. And here y square, y to the power 4 and y to the power 4 gone off. And only 2 to the power 4 will be remaining here. What is it? 2 to the power 4 is what? It's like 2 to the power 4 here. Wait. No, 4 to the power 4 to the power. Sorry, 4 to the power 2 means 16. Here it's also going to be 16. 2 to the power 4 is 16. 16 and 16 gone. The ratio going to be 1. ඔන්න ඔය ක්‍රමේ හරි ලේසි. මේක නිකන් ඔයාලට පොඩ්ඩක් එළියෙන් වගේ තේරෙනවා. එකපාරටම දැක්ක නිසා. This second method is the most easiest one. මේ ස්ටෙප් එකක්වත් ලියවෙන්නේ නැහැ. ඔයාලගේ ස්කිල් එක ආපු ගමන් ඔයාලා මේක ලියවෙනවා. දන්නවා මේ වගේ හතර ගුණයක් තියෙනවා කියලා ටක් දාලා මෙතෙන්ට උඩට දා ගන්නවා 16ක්. හතරේ පවර් 2 එක 16යි. ඊළඟට ඔයාලට තේරෙනවා මේ වගේ දෙගුණයක් මෙතන තියෙන්නේ කියලා. එහෙනම් 2 4 ඒත් 1/16 දා ගන්නවා. කපලා දාලා ඉවරලා 1 කියලා දානවා. කපන්නේ නැහැ. ඕම් මේක තමයි අපි හදාගන්නේ. MCQ ටෙක්නික්ස්. දැන් මේ තියරි එකත් අද මොළුවට ගිහිල්ලා MCQ ටෙක්නික්ස් එකත් අද මොළුවට ගන්න බෑ. පස්සේ වෙලාවට මේක try කරලා බලන්න. Just try this in a later time and you will become mastermind of this one. Right. ඔච්චරයි ඒකට. දැන් ටාර් ගාලා තව එක ගානක් හදලා අපි යමු Green's displacement law එකට. ඒක කරලා තව එකම එක ගානක් හදලා අපි යමු Green's displacement law එකට. මේ ඔක්කොම එක වගේ. මෙන්න මේක හදමු 6 වෙනි එක. පොඩ්ඩක් එක්සෑම් එකට කිට්ටු වෙන ගානක් මෙතන තියෙනවා. එක්සෑම් එකේ ලෙවල් එකට කිට්ටුවෙන් යන එකක්. පොඩ්ඩක් හදමුනේ මාත්‍යලා. right even here ටක් ගාලා අපි try එකක් දෙමු නම් මේකට ඔයාලට දෙන්න ඉන්නේ මේ generous time එක. I will give you more like another 10 minutes. 10 minutes වලින් try කරන්න. බැරි වුණාට කමක් නැහැ try කරන්න. මහා අමාරුවක් නැහැ. මම ආයෙත් අවශ්‍ය කරන දේවල් ටික ලියනවා. හරි. අවශ්‍ය කරන දේවල් ටික අනෑගේ දීලා තියෙන balls constant එකේ number දීලා තියෙනවා. Everything is given, even including the Boltzmann constant here. Right, your timer starts now. Last 10 seconds. Okay, time is over. It's about to discuss now. Time is completely over. Right. Okay. Now don't think about the rooftop because they asked about firstly asking about the energy absorbed emission by the sun. Right. So you have to only worry about the sun's dimension. Sun has a radius of r and the temperature of T. And you have to write this equation again, sigma a t to the power 4. Okay, right. What is sigma? You know that is 5.7 into 10 to the power minus 8. This value given here is the sigma value. It's a constant, universal constant. And our next one is the area. As I told you, area of the sun. Surface area of the sun is a sphere. So sphere has an area of 4 pi r to the power 2. Now for pi r is like this value. Radius of the sun is what given like 7 into 10 to the power 8. Like so 7 into 10 to the power 8 and square it because the radius r to the power 2. And the next one is the temperature. Temperature was given here. 6000 degree Kelvin is the temperature. 6000 and raise it to the power 4. I will do that usually as usual using my calculator and write the answer only here because in your exam you will get some values you might be able to use. That logarithmic table book asks your invigilators අනිවාර්යයෙන්ම තත්ත්වයක් දාලා ඉන්නලා logarithmic table වලින් ගොඩක් වෙලාවට solve කරන්න වෙන්නේ. පොද calculators අපිට පාවිච්චි කරන්න දෙන්නේ නැහැ ළමයි. අනිවාර්යයෙන්ම මේ වලින් ප්‍රශ්න දෙනවා. ප්‍රශ්න දුන්නාම මේ අවුරුද්දේ එන්න ලොකු ඉඩක් තියෙනවා. You have a great deal of chance that for this one to come. ලොකු chance එකක් තියෙනවා. And 6000 to the power 4. 6000 to the power 4. And the energy emission is very huge value. Sun තප්පරයකට දාන value එක හිතා ගන්න බැහැ. It's like 6.4 into 10 to the power 17 watt. එන ලොකු value එකක්. Okay, 1% ගන්න පුළුවන් නම් හොඳටම වැඩිනේ. 1% නෙමෙයි. 0.1% ගන්නවා නම් ගන්න පුළුවන් නම් energy crisis ගොඩාක් ඉවරයි. Right. Find out the power intensity of the solar energy per unit area. Of unit area මම පොඩි අවුලක් තියෙනවා මෙතන ගානේ area on earth surface කියන කතන්දරේ දීලා නැහැ ළමයි. එතන පොඩි අවුලක් තියෙනවා on earth surface. ඒක printing mistake එකක්. මට ඒක කියන්න බැරි වුණා. හරි. ඒක කොහොමද හදන්නේ කියන්න කලින් මම පොඩි diagram එකක් අඳින්නම්. You may really need to draw. Have a good look at here. If this one is the sun, right? Sun වල ඉඳන් මම පොඩි වැඩක් කරලා දෙන්නම්. පස්සේ කාරගෙන මෙන්න මේක ජියොමෙට්‍රිකලිම පෙන්නුවොත් තමයි ඔයාලට ඒක කරගන්න පුළුවන්. මොකද මේ જાතිය ගණන් මාර ප්‍රොමිනන්ට්. මෙන්න මේ වගේ ලොකු සර්කල් එකක් අතුලක් කියලා හිතන්න. This is what the radius of the sun. This is what the radius of the path of earth spinning of the earth. මෙන්න මේ earth එක කැරකෙන orbit එකේ radius එක මේ r2. එතන r of the sun, radius of the sun, radius of the path. කොහොම හොඳට දෙන්න. හරි. මේ ආපු එනර්ජි එක මොකද වෙන්නේ? Now spreading throughout this area. මේක අපේ earth එක දිහා විතරක් නෙමෙයි හතර වටේටම යනවා. Under certain spherical surface you are getting sun power that of 1 square meter of this region when closer to the earth surface. ඒකේ හොඳට තේරෙනවනේ. earth surface එකේදී හම්බ වෙන 1 meter කියන්නේ මේ හතර වටේම spread වෙච්ච sphere එකේ තියෙන 1 meter එකකුයි earth surface එකේ 1 meter එකකුයි කියන්නේ දෙකක් නෙමෙයි කියන එක තේරෙනවා. ඔන්න ඔය කතාව තේරුණාද ළමයි? This is really important to know. This point is absolutely extremely important. Right? කියන්නේ මේ හතර වටේටම විහිදෙන මෙන්න මේ ස්පියර් එකේ 1 ස්ක්වයර් මීටර් තමයි earth surface එක වදින තියෙන ස්පියර් එක. ඔය කතාව තේරුම් නැත්නම් මෙසේජ් එකක් දාන්න මම අමුන් කියලා දෙන්නම්. ප්‍රශ්නයක් නැහැ. හරි. මම මේක මෙහෙමම තියාගෙන මම පැත්තකට ඇවිල්ලා ගාන හදන්නම්. Find out the intensity of solar constant. Solar constant කියලා දාලා තියෙන එක නිසා විතරයි පොඩ්ඩක් හරි ගොඩ යන්න පුළුවන්. මොකද mistake එකක් සැරට වෙලා තියෙනවා. Alright, we found the amount, it's like 6.4. Okay, now intensity is what? Power divided by area. මෙන්න මේක ගැන idea එකක් තියෙන්න ඕනේ. sound intensity එහෙම කරලා නෙවෙයි ඉන්නේ නේ. sound intensity වල එහෙම මතකයි නේ decibel ගණන් හදද්දි මේ equation පාවිච්චි කරන්නේ නැතිනේ. Power is what? 6.4 into 10 to the power 17 watt. Divide that by the area. What is the area? This one. The distance from center of the sun to the earth surface is 1.5 into 10 to the power 11 meter. No, it's 11. 4, 5 into 1.5 into 10 to the power 11 meter and square. කොහොමද දාලා වැලියු ටික ගමු. solar constant එකේ වැලියු එක කීයද කියලා. 6.4 into 10 to the power 17 is going to divide by 4 by 4 by 1.5 into 10 to the power 11 square and bracket and get the answer. කලින් ආන්සර් එකේදී මොකක් හරි අඩුවක් වෙලා තියෙනවා. Somehow I am getting a very weird answer here. My answer is a very weird one. Somewhere has gone wrong. 6 to the power minus 6. උතන හරි මිස් වෙලා තියෙනවා. 10 to the power minus 8 එක හරි 11 meters. Power is given. 4 by මිරලා ලොකු 10 ගානක ආන්සරයක් දෙන්නෝනේ මේ කොතනක හරි මේ නම්බර්ස් වල මොන හරි අඩුවක් වෙලා තියෙනවා වගේ මට තේරෙනවා. හරි. Next one, the root of the material is density of 4000 kilograms per cubic meter. හරි. මේ මෙතන මේ value එකේ පොඩි mistake එකක් වුණානේ මම හිතන්නේ මේ හරි value එක පොඩි අවුලක් ගිහිල්ලා තියෙනවා. Right. Okay. Now we have to this එතන මේ value එකේ මට අඩුව හොයාගන්න නැත්නම් මේක මුකුත් ගන්න අමාරුයි. Next up is the Wien's displacement theory. After Wien's displacement theory, we have to go for another thing. What is it? Wien's displacement theory කරාට පස්සේ ළමයි ගන්න ඕනේ මොනවද මේ? Wien's displacement එකට පස්සේ ළමයි ගන්න තියෙනවා फक्त අරක Planck's hypothesis. කොහොමද ඒක කරලා පස්සේ කතන්දරේ අද දවසට ඉවරයි. හරි. මම දැන්ට රෙකෝඩින් එක පෝස් කරලා දැන් නම් විනාඩි 20කින් එන්න විනාඩි 20ක් කියන්නේ it's like what is the time is it now? 10 මාරයි. 10:55ට 10:35යි 10:55 වලට එන්න.